please be sure you have watched the previous Getting Started videos. We'll build on the concepts learned there. In this video, we will create a hallway table. We'll learn about using groups and components to better separate and organize the various parts of your model. We'll start by drawing the tabletop. Create a rectangle that is 14 inches wide by 48 inches long, and push-pull it up 1 inch. Now zoom into the corner and draw a line from this midpoint to a point on the lower edge. Depending on your preference, you can make this angle deeper or more shallow, and SketchUp will also give you an indication of an equidistant angle by turning purple and snapping to that angle. Finish your line and orbit underneath the tabletop. We are going to use the Follow Me tool to create a chamfer. We could manually follow the surface around the edges, but there is a quicker method we can use. Because we want to chamfer the entire lower surface, we can pre-select that surface, then pick the Follow Me tool and click on our angle to finish. Let's move the tabletop up to draw the legs underneath. With the Select tool, triple-click one of the surfaces to select all connected geometry, and move it up in the blue direction 37 inches. Given our top is 1 inch deep, that will give us a total table height of 38 inches. Orbit underneath to start drawing the table legs. Draw a rectangle, starting from this corner, that we can pull into a leg. However, before using push-pull, let's say we change our mind and we want the leg to be inset from the edge instead. If we select and move this surface, however, it begins to warp the tabletop. By drawing it on top of the other edges, those edges merged. This is a key behavior to making SketchUp fast and easy, but it's not what we want in this example. This is one of the primary uses of groups, which will isolate our geometry, preventing the edges from merging. To see this in action, undo the rectangle using Ctrl-Z on a PC or Command-Z on a Mac. Then, triple-click to select the whole tabletop, right or context click on the top, and from the submenu, choose Make Group. A new bounding box is shown around the whole top, and it now behaves as a single, unique entity. Draw the leg rectangle again. Make it 2 inches long, 1 inch deep from the corner. But this time it won't merge with the edges, so if we wanted to move it around, we could easily do so. Create some guides using the tape measure tool. Pull a guide 1 inch away from these lower edges, then move our leg rectangle to those guides so it's inset exactly 1 inch. Remember to move the rectangle from the corner point for accuracy. Now push-pull the leg down 37 inches. Using the Select tool, triple-click on the leg to select all of it. Then right or context click on it to open the context menu and this time choose Make Component. A pop-up menu will appear. You can name the component, and your settings should match these. We made the tabletop a group and the leg a component. At first, there may not seem to be a difference, but we'll see that there is a very important difference. Let's start with the similarities, though. A group or component binds the geometry together into a single entity. You can move, rotate, and scale the group as a whole. However, a tool like push-pull doesn't seem to work because you aren't affecting the actual surfaces, but the whole group together. To use push-pull and other tools, you need to edit the group. Use the Select tool and double-click on the tabletop. The bounding box changes, indicating that we are now editing the group. Still with the Select tool, click outside of the dotted surrounding box to close the group. Practice this a few times with our group and component. Double-click on one to edit it, click outside to close it, and do this several times. While you are editing a group or component, you can draw and divide surfaces and edges, use push-pull and other tools. But once you close the group, anything you draw is outside of the group, so it's important to know when you are editing or working outside of a group or component. With that understanding, if you did modify your group in any way, undo any changes back to our original tabletop and leg, and let's copy the leg to the back side. First, create a guideline 1 inch away from the back edge. Then, as we learned in the last video, start moving the leg, then press the Control key or Option key on a Mac to move a copy instead. Move the second leg into position using our guidelines. For comparison, also make a copy of the tabletop upwards so we can see what the primary difference is between groups and components. For the legs, let's angle the legs inward as part of the style of our table. Make sure you are editing the leg component, then select this lower outside edge and start moving it with the Move tool. The copied leg component is reflecting the same changes, and this is what makes a component very powerful. Any changes you make to one component are also made to any of the same components in the model. Move the edge inward 1 inch and close the component. For comparison, edit the copy of the tabletop and make some changes to it. The original tabletop stays the same because this is a group and every group is unique. So there is our overview of groups and components. Both help us to group geometry together, but each group is unique, where a component and any copies of it are instanced, so any changes made to one are made to all. As a general rule then, if you don't plan to copy an object, grouping it is fine. But if you think there is a chance that it will be copied, make it a component, and use groups and components throughout your model to keep objects separate and unique. Now let's return focus to our table. Navigate under the table and draw a rectangle between the legs that is 1/2 inch thick. Your width may vary based on the angle you created under the tabletop, but whatever the width, pull it down 6 inches. Now, triple-click with the Select tool and make this a component. Name it, and create the component. Let's copy this support piece and the legs to the opposite side of the table. Zoom out to get a full view of our table, then hold the Shift key down and use the Select tool to select all 3 parts. Now begin moving them down the length of the table and press the Control key, or Option key on a Mac, to make a copy and place them somewhere around the middle of the table, making sure to keep them lined up along inference directions. To know where to place them, we need to create a guideline as we've done before, 1 inch from the far edge. However, the direction these legs are facing is incorrect. We need to flip or mirror these parts. Make sure all 3 parts are selected and choose the Scale tool. Scale works by clicking to move the control grips. Any of the corner grips will scale everything uniformly. However, choosing a center grip will scale it only along that axis. Watch how this works by trying several of the grips. Pay special attention to the center grips, which scale along the red, green, and blue directions. If you squash the geometry through itself, you can mirror the object in that direction. To get a perfect mirrored version, watch the measurements box. The Scale tool works as a percentage. 1 equals 100%. 0.5 is 50%, or half the scale. 2 would then be 200%, or twice the scale. And if we pull the geometry through itself, it becomes negative, so -1 equals -100%, or a perfect mirrored version of our geometry. Undo any scale effects you have created. Select all 3 parts and scale along this center grip until you see -1, which the tool will also snap to, and click to finish. Now move the assembly into place using the corner of the table and your guidelines for placement. Next, let's create the front of the table. Zoom into a corner to draw a rectangle that is 1/2 inch wide by 6 inches deep. Then pull it across using the opposite leg as the reference. Select the entire table front with a triple click and make it a component. Now orbit underneath and copy this to the back, using inferencing for proper placement. Let's add a curve to our table. Orbit to a good front view and create a guide 1 inch up from the table front piece. Now edit the front component to draw a 2-point arc inside it. Drawing an arc is a simple 3-click process. Click once at the corner to start the arc. Click on the opposite corner, where the other side of the arc will be. Then pull up and use the guideline as a reference for how high to make the arc. Now you can use push-pull on the arc. Push it until it meets the back surface, which will delete it. Close the component. We won't create all the internal elements or drawers that a real table will have, but let's finish this example by creating the drawer fronts so our table looks complete. Draw a rectangle on the table front that is 3 inches by 15 inches wide, and pull it out 1 inch. Zoom in and create a chamfer as we did with the tabletop. Draw an angle, then select the front face as our Follow Me surface. Then choose the Follow Me tool and click on the angle to complete the Follow Me chamfer. We better group the geometry at this point. Triple-click to select it all. And if we were going to center the drawer and have only one, we could group it, but I'm going to create 2 drawers, so let's make it a component instead. Now a few guidelines can help with the placement of the drawer front and the copy. Place yours where you think they look best. Perhaps as a final touch, edit one of these drawers, and using inferencing to center our circle tool, create a small drawer pull. Then close the component. Delete any guides we've created. Paint the table if you'd like, or add your own details. The very best thing you can do is just to practice and play with SketchUp, using these projects we've built together or new projects of your own. As with previous videos, there is much more to learn about using groups and components, mirroring objects, Follow Me, and other powerful tools in SketchUp. So please continue to explore more of our videos and training content.